Assalamu alaikum. Andrey Markov was interested in studying an extension of independent random sequence. He published his first paper on Markov chains in 1906. Hello everyone, my name is Rakibul Hassan. Today I am going to talk about Canadian presidential election prediction using Markov chains. I have two passionate and hard worker groupmates, Mr. Nazmul Huda and Khamis. Let's begin with introduction. Linear algebra provides tools for prediction voting trends, especially by using Markov chains. In a Markov process, the next state of a system only depends on the current state and the transition matrix. In general, this project will use the 1982-2004 Canadian presidential election results to predict the 2006 to 2019 presidential election results by using Markov chains and variations of them. These predictions are then compared with actual data. Methodology. In this project, we will be attempting to perform our analysis by utilizing real datasets. Therefore, we will be collecting our data from different online dataset sources like Wikipedia, Kaggle, and so on. Firstly, Canadian election results by party. Secondly, past Canadian federal election result. Thirdly, Canadian electoral system. Let's move on our next presenter.
Assalamu alaikum warahmatullah. I am Muhammad Nazmul Huda. Now I am going to discuss about visualization of the data set. Actually, we collect our data from a trusted website. The link is in our report. So here is our data set. We collect from 1980 to 2019, and we try to do some visualization using Azure. For predicting result from 2006 to 2019, first we use stochastic matrix with average transformation matrix. So the T1 is the transformation matrix. We calculate the transformation matrix. Then we find out the first A1 stochastic matrix. For our first stochastic matrix, we calculate 1980 to 2000 and find out the transformation matrix, then divided by 6. Thus, this is how we get our stochastic matrix, first stochastic matrix. For the first method of predicting the popular vote, we use Markov chain. In here, A1 stochastic matrix, and we multiply with the stochastic matrix with 2004 popular vote, and in this prediction we find 2006 popular vote, but it was incorrectly predicted. And similarly, we also find 2008 popular vote, but it also incorrect predict. But in 2011, the popular vote prediction was correctly predicted. Similarly, we do the same thing till 2019, but we only get one correct prediction, and that is 2011.
I'm going to be taking over from here. So in this slide, I'm going to be talking about the result of the prediction with the changing probability vectors. So over here, as you can see, this table, it shows all the years that we're trying to predict and see if it actually matches the real data set. So for the first one over here in 2006, you can see it's not correctly predicted, and the average is 3.05, which is similar to the Markov chains. So how we do this is by using the stochastic matrix A1, which is derived from previously, and multiplying it with the data sets for each year. So for each year in 2006, we use a data set and we put it in a probability vector form, and then we multiply it with the stochastic matrix, and then we'll get that result. The result will subtracted from the original data set, and then we get it, we put it in a root, and then we just divide it by 3 because we have 3 parties. Okay, so for the 2008, we have the conservative party here, which is correctly predicted, and the average error is 3.50%. 2011 is also correctly predicted. For the conservative side, they have won the election, which also correctly predicted. 2015, not correctly predicted. Last but not least, the 2019 presidential election was correctly predicted, and the Liberal Party have won it. And yeah, so for the overall average error for this method, it equals 5.95%. And how we got that is by adding up all these and just dividing it by 5. Okay, so moving on to the next slide. Over here we got the result with the changing stochastic matrices and probability vectors. So over here, the only difference is we calculated the extra stochastic matrices. So for every year, we get the new stochastic matrix, multiply that with the given year. So how we got the stochastic matrix, the next one is by adding up the transformation matrix, which is for 2008 will be will add up from T1 to T7, and we multiply it by and we get the average of that, which is A2, the stochastic matrix. And then so on for 2011, it'll be the same. We get A3. For 2015, we get A4, and last but not least, we get A5. And then we multiply it by each data set for the given year that we want to try to predict. And over here we get the overall average error for this method, which equals 6.54%. As you can see over here, the correctly predicted years are the same, but the average errors are slightly different, as you can see here. So yeah, moving on to the next slide. And for the conclusion, to conclude this, it's safe to say that in general, the presidential elections in Canada were not correctly predicted using Markov chains or a combination of the stochastic matrix with a vector of probability. 50% of the elections were accurately predicted by the most precise methods, even though we didn't get it fully correct, but it was decent. It was a decent amount. So although it wasn't correctly predicted, the linear algebra should not be discounted definitely as a means for forecasting elections. Using a stochastic matrix adjusted for the political climate should produce more accurate results. So yeah, that's all from us. Thank you for tuning in, and assalamu alaikum wa rahmatullahi wa barakatuh.